день.
Hi.
Однажды задался темой такой.
Once I had a question, how secure are our conveyors? Are there any vulnerabilities, problems, errors in what our DevOps are doing? What we can see here, I develop conveyors myself. We develop a lot of conveyors, I mean our team. Can we find anything bad there? And my presentation is about that, about peculiarities of how we audit the conveyors, which are not in the format of YAML files, who are met here and there. I work in a large insurance company as DevSecOps. I worked in different areas, and well, it's written who I am. Well, I developed a WASP prompt. Now let us look at the audit scheme that we can use for detailed auditing to find problems. Briefly, what we usually have. We have DevSecOps or DevOps, developers, testers, and some other members of the development team who can develop their own conveyors to automate something. They build a conveyor, and usually the conveyor is classical one. It's a YAML file, and it's in Git. You can attach practices and check it. We use DevOps, and most of the conveyors are delivery conveyors, conveyors to deliver content to our servers. They are not stored in Git. I'm going to tell you later about it. We have a ready-made conveyor, then we can automatically launch the audit for such a conveyor and see the result. If we see vulnerabilities, we can do something about them. Each conveyor is a set of steps, a set of actions which are programmed there. And what is interesting for us, the scripts, because vulnerabilities or malicious things can be found in scripts. And some steps, it's not always the launch of the script, maybe an external plugin which simplifies interaction with something, because it may contain a functionality which contains a lot of code, and you can address a service to reduce, to shrink your conveyor. Conveyors can use their own variables for that particular conveyor. For simplicity, you store everything in one place, but conveyors can also use groups of variables, sets of variables shared between different conveyors for convenience, for simplicity. Accordingly, to understand auditing, to understand the process, let's look at it from a different angle. In our case, if we created a conveyor in UI, it is stored in the database in our CI/CD system, and we can take it only by addressing the API. So it's a bit more difficult than analyzing YAMLs in Git. What can we get from conveyors? The variables, the steps in the conveyors, and what else? Scripts of different kind. It's interesting that we can even take logs of each conveyor step which are formed in the process and see if there is anything interested in. For example, we can parse all the strings with error, security, vulnerability. It will help us to find problems because the developer doesn't care about the conveyor. For him, the main thing is the application. It works, it runs, he even doesn't go into that conveyor. So we get this information and let us think about what we can do, what we can find there. In general, we can find information which may be sensitive, logins, passwords, secrets of all kind, even IP address or name of a server is not very good if it is disclosed and not hidden in some variable. So we can find vulnerabilities and errors, which are not vulnerabilities, but we have to trace it. For example, an error when a trigger for the conveyor of the delivery to production is tuned to feature branch that we don't know about. So the corporate rules said that it should be release branches only that we know that are acceptable for the company. What kind of examples we can have? What kind of vulnerabilities we can have? Disclosure of secrets. For example, we can see that we can see a potentially dangerous instruction which uploads all the variables. It's useful for tuning the conveyor, but at the same time, we have a risk of disclosing secrets. So you may disclose the token, at least part of the token. We can see the variables of the environment, and they also can be disclosed here. The second variable goes away as a link. It looks as if it's secure, but what else can we see? In UI, it's nice. You can see application of deprecated plugins, which can be revoked by the developer because he deleted his GitHub account and marketplace account, but an intruder can recreate the same kind of account and then compromise this plugin just by publishing a new version, higher version, and we can download it without thinking that it may be malware. Besides, it may be some arguments which are delivered to executable scripts, and they can be transmitted through unsafe channels. There is a script which is called at one of the steps, step 2. It is called from Git. We cover it with our SASP. We can find vulnerabilities, but the variables are sent in an insecure way. And then plugins can have insecure parameters. For example, the password can be sent without masking. We mentioned it before. And the password entry form it doesn't have protection against overlooking. The password is not replaced with asterisks there. Then some dubious instructions, strange instructions. If we look at malicious codes, we can find such instructions. Then checking the certificate change, insecure algorithm of service-to-service interaction. What else can be found? For example, transmission of secret from vault in an open way. We see the variable there, a dangerous parameter. Some people may say that the continuation of step 2 that you can see now on the screen is not necessary if it's just a deploy of our application on 2 nodes. If it is crashed on the first node, why should we install it on node 2? Well, yes, you can manage jobs in that way too. Disclosure of login also can be dangerous in some organizations. Variables are stored in separate entities in the conveyor, and you can call them and you can store them in an insecure way. And this is an example of we forgot to close the lock and disclosed the secret. The interesting thing is that our RGD Ops showed me that even if we found a secret, replaced it with a call from the variable where it is stored locked, but if we go to the log of conveyor, yes, you can see the secret openly, and this is the way you can see it. You protect it. It seems that you protected it, but actually you are not protected. You have to delete, you have to clean up all the history to be secure. Groups of variables, they can be stored in different conveyors, and this is an example of how insecure it may be. Look at this. Allow access to all conveyors. There is a click there. There is a tick there, and developers can create a conveyor and read all the variables, even if they are secret, because this tick allows them to do that. And the intruder, the hacker, can create a conveyor with those in variables with appropriate rights. He can print all that and use the same variable in different conveyors. What about statistical code analysis? Well, if you have YAML, some steps can be omitted. Export from the database through API files of the YAML format. Then an interesting case is to get from YAML the scripts. Our steps can contain scripts, and in order for SAST to process them correctly, you have to take it from YAML to a separate file. You can see the example in Python, command line, and PowerShell. I tried to evaluate how realistic is this audit if you do it manually. 6,500 containers contains about 7,000 steps. You can see 7,000, 6,000. It's impossible to do it manually. As long as you do it, well, you will be tired a lot and you will make mistakes. You have to export all your conveyors. In order to export them to SAST, you can take all the entities that you know, we take them through APIs and put them into the file system as separate files. Accordingly, we can find most of the vulnerabilities in the files which contain scripts. And by putting scripts to separate files, you will find a lot of vulnerabilities. because bad parameters is not the worst thing that you will find there. And there is an example of how you can get all the scripts. Our company uses a lot of external plugins. You can see only half of the result. And each script, each plugin contains a script. And you can spend a lot of time in Java DevOps
плагинов в Ямлик я столкнулся с тем, что
by putting scripts to YAML.
нет понимания.
I saw that we cannot understand what kind of plugin it is. There is no name. There is only the IP. We need a conveyor with all the codes, all the scripts with their IDs, and realize what we can have. This is a file structure. This is what we get. We say we have YAMLs, we have scripts, and then we send all that to statistical analyzer, SAST, for analysis. And this is what we do. This is the last step on our scheme. So we sent it to SAST. I told you what we can find there, and let us have a look what kind of rules it may generate. For example, in pip or SSH, you can see a parameter that reduces security. Such parameters are not required often because we may have certificates at our servers, some other mitigating schemes, so we don't need such parameters. You can eliminate them, and this is an example of how to disclose such problems. We use a lot of builds with MS deploy, and there is a parameter which I mentioned before. ChatGPT, for example, helped me a lot. You can ask him what kind of parameters we can have here and which of them are insecure. And from second or third iteration, it can tell you what is insecure. It's much easier to find insecure parameters in this way. You can see the JSON here. We are in DevOps, actually. It's not always YAML. Some rules are focused on JSON. An interesting case, as I told you, putting all variables into a log. On your left, you can see the log of the conveyor, part of our system token, and you can deploy anything if you get it. So in such cases must be disclosed and detected. How can you get all the parameters, all the variables from one point? Deprecated plugins. Some plugins do not have anything but IP address, and that's all. So you will have to spend time to download the plugins and create a rule for them. That is the rule. An example of the rules, vulnerable parameters of plugins. We can try to find what I show you in the screen. This is the way the plugin may look, and the string, the line where we make the rule. One rule for statistical analysis. To conclude, we can say that we have the following ideas for us to invent the rules. First, we must see what kind of languages we use in the company, what kind of software we use to build the trees for delivery And then we must have a list and then see what kind of parameters they will use, which of the parameters are not secure enough. After the first iteration, it's necessary to look at all other constructions which are not covered by our SAST for a particular language. Look at several repositories, look at all the files, and see that because SAST sometimes can miss some of the vulnerabilities. Maybe we have something very specific for us. An interesting case is to understand what kind of normative documents and our internal documentation can become a rule for statistical analysis of the code. We make an interesting case when the basic image is changed, but all the rest is the same, and you don't have to use the same image all the time. It saves some time, and it helps us to look for the cases when developers use non-standard tags. It can be anything. For example, launching the delivery conveyor from a wrong branch. And we must look for such lines of code which would help us to disclose such cases. It's also useful to understand how DevOps automate the conveyors, how they generate the conveyors, what they use, what kind of requirements they have. Now, searching for secrets. Of course, vulnerabilities can be searched, but part of the vulnerabilities are actually vulnerabilities related to sensitive information. How we can find such information? What can we do? We have variables, and we have to export them into a text file. So variables, text, and search of secrets. For example, git leaks. We launch the audit, git leaks, and disclose vulnerabilities, and we can backlog them. And this is the method. We can download everything in the text file, and then each text file can be analyzed and searched. It's useful, actually, because we can read it. The variables should be such as they can be searched, they can be readable, so that later, manually, we could visually see what kind of secrets were missed. Talking about variable groups, they are separate entities, and it's interesting to have information about who created such group, who was the last to change it, because this is a violation, and we can find the person who did it. And then we can delete all that and hide the secret under a lock. So it's simple with the method. We just send the file for scanning, run git leaks, and it's a simple conveyor. We launch it several times a day, and all information from all our network is downloaded. We can see how we work. Git leaks is stored in the log, and each launch of the conveyor is kept for some time, stored for some time, so we can see what happened. If we don't have time right now, we can do it a bit later. Variables should also be stored for some time for auditing. It would be able for you to look through. We store them for some time. It's good for auditing. Now, how can we react to all that? We find vulnerabilities, but what can we do with them? It's only logical that the primary thing is to disclose vulnerabilities, and then we must correct them. This is the only case. We can fix some of the things easily ourselves, tell the users that they shouldn't behave that way. What else? Each person is to decide for himself, but as far as we are concerned, we send letters, and the letter contains information about vulnerabilities. If the statistical analyzer found a vulnerability, we have a letter, and we can send that letter to the person who made the mistake. A developer will look at the letter, eliminate the error, and it helps us not to increase our debt log, debt pipeline reaction. This is, you can see the audit there, and in the letter you shouldn't disclose the secret, by the way. So you go to the audit log, and then you see what happened, and then forget about it. Recommendations. Recommendations about statistical analysis is to regulate not only the development and code security, but also a responsibility for conveyor security. Otherwise, it's difficult to control it if you have no rules. When you build the rule for SAST, it's good to make it long. Links to internal requirements, links to best practices, recommendations, what has to be replaced by what. If you give it to DevOps, to developer, because you use a variable, it's false, change it to true, make it true. A simple recommendation will save a lot of time, because not all the people read those recommendations. They can say, well, it's false, let it be false, no problem at all. And this process has to be automated, otherwise it's not a process, it's just an audit, a manual audit. Secrets should be found everywhere, even in the places where you don't seem to find them, because any build can disclose any kind of secret information, and you must have a rule to find such information. This audit has to be carried out as often as possible, several times a day, very quickly, covering all the conveyors in the company. As I said, it should be readable as much as possible, and you have to store the audit artifacts for some time at least. From time to time, you have to check what you downloaded. If you developed a rule which found nothing, so let us see whether you need such rule or not. It turns out that you don't have to eliminate all vulnerabilities that you found, because you can say that they are of low level of criticality. There is no sense of eliminating them right now. For example, by
The second
switching
case is
on
where
the
you
certificate, it may so
include
happen that
certification
you don't have
validation
enough
in the chain.
certificates,
You'd
and
be
that's
lacking some
why
of the certificates.
Или в процессе, не знаю, отката может что-то произойти, и на самом деле уже звучит не очень хорошо.
So if you roll it back, that will not be as preferable.
Команды сами разбирают
We are working through the backlog. Nobody is rushed.
уязвимости, и когда-то этот бэклог
The
будет
teams
разобран.
process vulnerabilities at their convenience, and they'll get through it eventually.
Перелистнулся, не перелистнулся? Да, перелистнулся. Примерно статистика.
Next slide.
Сложно
Here are
оценить,
some
оказалось,
rough
количество
stats.
тех правил, которые вообще удалось написать, потому
It's
что
not as easy for custom rules
хоп устранили на следующий день, и в статистику оно не
because
попадает. То есть,
it gets fixed overnight and it doesn't get included into the statistics because our analyzer for this doesn't export
там, начальной и конечной точкой того, когда мы вообще этот
if
аудит
it,
начинали.
the data point,
В такой статистике
if it's
могли потеряться. Ну,
rectified during the audit itself. So some data points may be lost there.
именно в сборке это в основном, как мы видим, большой
CI/CD vulnerabilities in builds mostly occur due to obsolete deprecated plugins. We are cleaning them up. And then there are vulnerabilities that have to do with certification chains. In delivery conveyors, most of the issues have to do with incorrect certificate validation. Insecure delivery of apps to production, that's what the conveyor is for.
Ну, если интересно подискутировать, есть контакты.
Here are my contact details if you want to start a conversation.
И необходимо оценить доклад.
And do rank my presentation if you liked it, like it.
Обязательно ставьте. Нам очень важна ваша обратная связь.
Do provide your feedback. We appreciate it greatly.
Вопросы можно задать
Now on to
в
questions.
микрофонах.
We have mics in the aisles.
Лучший вопрос, который нужно будет выбрать.
Best questions that you'll have to pick will be rewarded with a book from Peter Publishing House. You mentioned analysis of logs. Since it takes so many steps, do you have different sets of rules for logs, scripts? Have you considered some other tools to identify misconfigurations?
Пока не было такой идеи. На самом
No, we haven't considered a different tool yet.
отдельная тема доклада.
Looking for problems in logs merits a separate presentation.
Достаточно сложно, как оказалось. Ну, то
It's not as easy to export them in the first place. The API that is there
пока ты
doesn't
выгружаешь, и пока ты
support easy exports. So it takes some time to export, it takes some time to analyze,
Да.
they get purged and conveyors get fixed during that time. It's a separate presentation, but you have regular expressions for that. It's not that complicated. But it's not about misconfigurations mostly. You can get them from conveyor experts. Or do you mean misconfigurations of conveyor software? You had an example about secrets in logs. No. Get leaks does this in a couple of minutes across the thousands of conveyors. Okay, thank you. Hi, Alexander Gadai, WordPage Security. Thank you for the presentation. I wanted to ask about regular expressions that you come up with. They are pretty scary and complex. Do you have to modify them sometimes? And what if you delegate it to someone else? You didn't write it, you need to first read it and then modify it. Is this practical? What's your take on this?
Речь была про вопросы, связанные с вообще применимостью.
This is apparently about applicability of regular expressions. Why not use proper SAS rules? The expressions are long. Let's take the example with allow one trust, the variable. It can be called with true or false, or 1 or 0. Sometimes it's JSON, sometimes it's a YAML file. Sometimes it's embedded into a configuration in JSON in some app, so it's not called by the conveyor. It's just a config that the developers have on their own. So if you account for all of this, it's a long expression where this variable can come up at all. We haven't had cases where we delegated changes to the regular expressions. It's easier to do this on your own. There was a third part to the question, right? Well, yeah, it's just that it's a bit too complex. There's a workshop on reg language tomorrow, there are new approaches. It's human readable, and you can set finer conditions there. But I get your answer, thank you.
Сергей, добрый день, спасибо за доклад. Было очень интересно.
Thank you for the presentation. Hi. Very interesting challenge and a great solution. You mentioned false positives. How do you manage output to prevent repeat false positives? Is there a centralization for this? The secret is still in the history of commits. You've discovered it, but you need to mark it somehow, that it's a false positive. And when you recheck it, to exclude it, not manually. Do we have some centralized output management thing? How do you handle false and true alerts? In SAST,
Там есть функционал триажа простейший, да, отклонить или принять.
There is triage functionality, accept or decline. Very basic.
Если брать там поиск секретов, да, и
And it works. To your question of secrets, where you just run git leaks,
как я говорил, несколько раз в день происходит, конечно, он будет
you launch it several times a day, and each new run will have the same vulnerabilities pop up.
Есть там условный JSON-чик, в который я вписываю все исключения.
In my case, there is a JSON where I enter all the exceptions. They are not flagged anymore. I add a link to the backlog, so I'm not seeing them anymore. So you have SAST tool for triaging, accept, decline, and in other cases, you have something in-house. Yeah, we don't have a centralized system for vulnerability management. That's why it's like that. Okay, thank you. That seems to be it. Now you have to select the best question. The last question about updates to false positives. Please come up on stage. To the left, you'll get a gift. Thanks a lot. Thank you.